A very good morning, everybody. In the today's class of robotics, we'll be dealing with the homogeneous transformations with respect to an example problems. As we have problems or the basic theoretical representations regarding the formulations which were being utilized for solving the problems in the case of two-dimensional accuracy, three-dimensional accuracy, as discussed in the previous sessions. And in the today's class, the application of those formulations in the real-time basis, we need to calculate the end effector position upon shifting the coordinate frames and nominal transformations, that is nothing but the translation existing in the same coordinate axis, and with respect to the theta, the changing of the position related to the end effector from one coordinate system to the another coordinate system, and is being compared with respect to the base coordinate system. As we already know that after the transformation, either in the translation towards the another axis than the existing axis, or rotation or revolution considered, and those will be calculated the end effector position. Those in the sense the end effector position after the translation, either of the rotation or revolution or this prismatic movement, the end effector position for each and every joint position after this transformation has to be computed with respect to the base coordinate system existing at the origin point. And the entire formulations that we have been discussed in the previous class regarding the x-axis, the trigonometrical values in the case of this matrix formation, towards the x-axis, what's the position, towards the y-axis, what's the position, and simultaneously towards the z-axis, what's the position of transformations. We have a detailed look. And in the today's class, we'll be applying the values and calculating those with respect to the substitution of those results in the formulation. Seeing the first translation of homogeneous matrix. So translation clearly specifies that it's a prismatic movement. It's a prismatic movement. So prismatic movement in the sense, the movement for each and every link will be existing towards either positive x-axis or negative x-axis, or positive y, negative y, positive z, negative z. So we are having 6 degrees of freedom. It has been discussed in the coordinate systems of the robot also. And majorly it will be coming under the Cartesian coordinate systems. And any coordinate systems in 4 different coordinate systems. First one Cartesian coordinate system, second one cylindrical coordinate system, third one spherical coordinate system, and fourth one is an articulated type of coordinate system, articulated type or jointed arm coordinate system. So for each and everything, each and every coordinate system, we are having some specifications. So first specification related to the Cartesian coordinate system is will be having only the prismatic movements in 3 different axes, either x or y or z. We are having only the prismatic movements, so sliding movements, to and fro motions. That's it. The positive movement, that is to motion, and negative position in the same axis without changing in theta. So there will not be any theta variations or phi variations regarding these movements. Hence, in the x positive or negative, y positive or negative, and z positive or negative only will be having the variations. See here, If the reference plane, if after the sliding, if it is mutually linked, the links in the robot are mutually accessed, then there will be a movement upon its extensions in different directions, but particularly limits to the parallel motion with respect to the base frames, either x-axis frame, base frame in the sense, and y-axis frame, base frame, and z-axis frame, base frame. So parallel movement in the sense will be moving in the same axis. Why? Because we are doesn't having any of the theta deflection. So theta deflection కనుక ఉంటే, then it will be having a linear movement, right? Linearly increasing, and even upon changing the theta value, will be having the non-linear movement also. And upon this orientation and position also will be having this movements, nothing but the variations with respect to the theta. On and gratitude, the, the identifying or the slide which is showing to you is related to the Cartesian coordinate system, because it is clearly specifying that it's an AB of Px, that is nothing but a link from the origin position from A is being sliding with respect to the base of A, and link B is also getting slided, and that would be towards the x-axis. Simultaneously, from the origin position to link A will be getting attached, and based on the link A, link B will be getting slided, and regarding the or with respect to the y-axis. So to and fro motions simultaneously towards the z-axis also here, and hence the values here will be substituted with respect to x-axis, in the sense we will be substituting here based upon the links, either it may be of the link 1 or link 2. So here A and B. So here it is clearly specifying that the robot is constituted in the three-dimensional coordinate system related to the x terminology, based on only this A and B links considered to the base frame. So link 1 from the base to A, and A to B, that is link 2. So two links we are having, and hence if base joint is considered, that is a zero joint, we will be having two joints. But as per far as our subject phenomena is considered, n number of joints, indeed to find the n number of joints in the robot, the formulation here it is n number of links minus 1. So L minus 1. Here we are having two links, and hence we'll be having one joint. So 2 minus 1 will be considering as a one joint. But as per the universal strategy is considered, joint 0 has to be considered, and that will be as the base, that is constant and fixed 0 0 0 to the origin point. So here the translation, clearly we can say that it's an prismatic movement. Prismatic movement in the sense sliding motions related to the Cartesian coordinate system. So movement will be considering in the x-axis, movement will be considering in the y-axis, movement will be considering in the z-axis. So there is the basic reference or translation will be coming soon. See here, suppose reference system B is translated by a vector. So here we have been given any vector OAB is equal to a change in the OX regarding OAB, and next AB link towards the Y towards the Z, and its transformation. So here all transpose reference to the system A. Hence there will be one link. That link is being existing to that particular phenomena, and this one link will be existing with respect to the second link, which is getting slided over this, but another end effector will be having at an edge point to the link 2. So even it has been slided over the link 1 also, the end effector position will be changing from link 1 to link 2. And that after this translation or sliding is nothing but the prismatic movement only with respect to one axis only, it is sliding. For instance, we can have a detailed look regarding this in the diagrammatically. I'll be visualizing to you once. For example, end effector will be having its sliding movements. Position will be getting changed with respect to its jointal positions, and finally the end effector constraints. End effector constraints will be accessing with respect to the changes in the orientations or orientations also. That also will be having a detailed look here. Yes. In the classifications of robots, we are having a detailed look regarding this prismatic movement. Yes, this is the prismatic movement. See, this is the link 1. As per the today's session has been completed, say this homogeneous transformation, and towards the x movement, towards the y movement, and towards the z movements. We are saying these 3 different axes. All right. So we'll be having a detailed look regarding this. See, in the industrial sector also, as per its work volume or movement is considered, this is the link 1, and this is the link 2 existing. There will not be any theta orientation or phi interpolation. Theta lo change undadu, phi lo change undadu. Only that will be getting slided over this. And only z axis, positive z axis movement, negative z axis movement. So positive z axis movement link 2 kanaka parameter link 1 base మీద kanaka stud అయితే automatically the end effector position also will be getting changed. That's what I used to visualize, right? So for example, this is an fixed joint, fixed link. There is an extensible link. This is the link 2, which is sliding over this link 1, and will be having only the x position of movement. So, and this is the another movement, and have a clear cut look in the diagram. Each and every position is mutually perpendicular to each other. Mutually perpendicular to each other. So this is the z-axis, and this is the x-axis, which is mutually perpendicular to each other. And this is the z-axis, and this is the y-axis, mutually perpendicular to each other. When compared with respect to the x-axis and y-axis, it is mutually perpendicular to each other. So 3 different axes are mutually perpendicular to each other. And those sliding motions of the end effector will be getting changed even if any one link also has the change in its movements. That's what I used to represent. So yella change avutayandi. See here once, if this y moment, if it is existing in the presently higher locations, top dead center, let us consider top dead center existing this x position and y position in the top dead center of this z, right? And if this slide has been lowered to bottom dead center, this entire equipment link 2 and link 3 will be getting towards the down, and XYZ position of this end effector is presently, let us say that towards the Z it is being having, towards the X it is being having, towards the Y it is being having. For example, X1, Y1, Z1. And when it has been lowered down, simultaneously the end effector position also will be getting down from this position to bottom dead center position. Something around it will be here. And obviously, then we'll be having a change in its X comma Y comma Z. That change of position need to be highlighted. Those are nothing but the homogeneous transformations. So only related to the X terminology. If theta is existing, the theta will be applying in the homogeneous matrices related to the trigonometrical values towards the X, towards the Y, and towards the Z simultaneously. Right? We'll be having a detailed look how these transformations will be applied. So from vector transferring from that substantial to the with respect to basic position. See, have to be considered A transpose B to the position at that particular axis, presently existing axis. So OAB position will be, present position will be highlighted, and the change in its positions will be applied here. Or else the change to, regarding x-axis 2 units will be changed, regarding y-axis 3 units will be changed, regarding z-axis 3 units will be changed. So 2, 3 and next again 3 will be substituted here, and already existing base x1, y1, z1 values will be represented here. So upon calculations we will be getting the new point. So these are the new coordinates x2, y2, z2 after the transformations. That is what sliding action. So you need to calculate the position of transformation constrained from the base A to the end point. We need to transpose the transformation of matrix from the position A to the B, and the product of the point which is existing from the base point to the end point, from the base point to the end point, right? So we'll be having, after that, if there is any further extension with respect to the next frame also, nothing but links వచ్చేసరికి link A, link B, link C కూడా ఉండొచ్చు. అండ్ బేస్ దగ్గర నుంచి లింక్ ఏ దగ్గర నుంచి నెక్స్ట్ లింక్ బికి. సో అట్లా మనం మళ్ళీ క్యాలిక్యులేట్ చేసుకుంటే ఆల్రెడీ వచ్చిన పాయింట్ ఏదైతే ఉంటుందో ఆ పాయింట్ని ది నెక్స్ట్ పాయింట్ కనుక మనం మరలా కనుక యాడ్ చేసినట్లయితే ఆటోమేటికల్లీ విల్ బి గెటింగ్ ది ఫైనల్ ట్రాన్స్ఫర్మేషన్ మ్యాట్రిక్స్. సో హౌ విల్ బి హ్యావింగ్ ఏ వన్ ఎగ్జాంపుల్. See here, the reference frame system B was translated by a vector OAB. So that is first one already given, OAB, nothing but origin point to AB, and vector 6 having x1 value 6, y1 value -3, z1 value 8. With respect to the reference frame A, it is being slided. Calculate the components AP, nothing but this is the values that has been specified here. We have to calculate this value transposing, and e values ఎలా obtain చేయాలి అనేది of the vector P. Who's the components with respect to the frame B, or these are the representations. So these representation values has been given here already. So you have to find out this AP of X, AP of Y, and AP of Z, right? So these values need to be obtained, and with respect to the base frame B have to be calculated. So base frame B లో మనకు కావాల్సిన పొజిషన్ ఆఫ్ వెక్టర్ కూడా కావాలి. ఎందుకని we have to substitute that position of the vector. See here already substitute that position of vector, right? And ఎంత ట్రాన్స్లేట్ చేస్తే, ఎన్ని యూనిట్స్ ట్రాన్స్లేట్ చేస్తే మనకి కొత్త పాయింట్, నథింగ్ బట్ దిస్ position after the transformation from A to the end position will be achieved. So A నుంచి E వరకు రావాలి అని అంటే you need to confine the product elimination with respect to the base B to E. So you have to impose those values in the calculations. So what are those values? Those values has been given clear cutly. So with respect to base frame in the question, they have given that with respect to the base frame B, only the translation will be considered, and the translation will be extended in the x-axis with respect to the 6, and the y-axis with respect to -3, the z-axis with respect to the 8. So how to translate has to be taken with respect to our homogeneous matrix. See, homogeneous matrix, center matrix, and x, y, z. So these three values will be applied here. See, in the formulation also having the clear cut vision, x, y, z. So substituting which need to be transferred 6 units minus 3 8 applied here. And next, regarding which point, so we need to find out regarding the base frame from the point A to N point E. We have to find out that. But before finding that, in the question it is clearly given that the rotation or sorry, the translation need to be commenced with respect to the base frame B, but the reference frame also considered with respect to the B. So if it has been considered as a base frame B, then we have to know the value of the vector related to the B point. Hence, it is -2, 7, and 3. -2, 7, and 3. So this is the consideration. Have a look. Applying with respect to the base frame B, the point B to E. So A of transpose to B and base frame of B with respect to the E. So this is the translation need to be commenced regarding XYZ, and this is the reference frame. So reference frame values has been given, so that you will be substituting here, and upon multiplication factor you will be having this value. So see, have a look. 1 into -2 plus 6 into 1, 0 into 7 0 plus 0 into 3 0 plus 6 into 1 6. So -2 plus 6, that is 4 value here. Simultaneously have done the calculation. So row into column will be having one value. So 0 into -2 0 plus 1 into 7 7 plus 0 minus 3. So here 7 minus 3. We are having 4 is the value. Simultaneously 0 into -2 0, 0 into 7 0, 1 into 3 3 plus 8 into 1 8. So 8 plus 3 11. So 11 is the terminology value, and it is an unitary matrix 1 into 1 1. And this is the coordinate axis or values of or the position of the end effector with respect to the base frame A when it has been rotated towards the component base frame B, right? So these are the after translation, the position of the end effector will be x2 value, y2 value, z2 value. So here is the ax value, y value, z value. And in the question also it has been clearly observed that find out the position of the end effector with respect to x value, y value, z value after the transformation. So these are the values after getting the transformation. So that is only considered in the case of prismatic movement to position and fro position, extension or contraction. That is the condition it has been taken place. Next thing, considering the next joint, calculating the vector which is the result of translating the vector AB. The position has been given from the base frame considering from A, that is x14, y14 and z111 all transpose the same. The value we have got in the previous we are considering here. By using the transformation matrix, A transformation with respect to the O transformation is 6, -3, 8. That is the position has been 6, -3, 8. So what's the denominator step we are having? First one, see, this is the end effector position in the previous calculation, that is -2, 7 and 3. The first position will be here, and after translation we have got the result that to OA the position of the end effector is here 4 comma 4 comma 11. And next, now the transformation with respect to the O when it has been referred. So after translating from point here to this position, we are having 4 4 11. But after this transformation, when it has been visualized from the base position, the reference value is 6 comma minus 3 comma 8. So we are having clear cut definition here that after translation, the end effector position will be entering from one frame to the another frame. It is entering from one frame to the another frame, either of XY frame to the ZX frame or XY frame or YZ frame, right? So that frame need to be compared or analyzed with respect to the base frame. So base frame మనకి ఇక్కడ ఏమవుతుందంటే origin frame అవుతుంది. Origin frame అవుతుంది. That is the origin frame. Right. So when it has been compared with respect to the origin frame, the values are 6 comma minus 3 comma 8. Translation with respect to the origin frame. Right. How the translation is progressed and what is the fixed translation and how it has been compared. And it has to be referred. And what is the value will be identifying here. See the translation value again given, that is 6 comma 3 comma minus 8. And with respect to which values? With respect to the base frame, O frame, base frame, origin frame. So origin frame values into 4 comma 4 comma 11 that we have been obtained. So that position will be applied here, and again the cross multiplication need to be get done, and we will be getting the values. Right. So 1 into 4 4 plus 0 into 0 0 into 4 0 0 into 11 0 6 into 1 6. So 4 plus 6, that's 10. 0 4 0 minus 3. So 4 minus 3, that is 1. Next 0 0 11 plus 8. So 11 plus 8 19. And unitary matrix is 1 into 1 1. So we need only the x2 value, y2 value, z2 value. The obtained value upon extinction, it is compared with respect to the base axis. Then we are obtaining the end effector position value as like this. So 10 in the case of x-axis, 1 in the case of y-axis, z in the case of, 19 in the case of z-axis. These are the results related to the translatory matrix. Let's have a look regarding the rotational strategy. So we all have the aware regarding its rotation with respect to x-axis, in the sense the rotation need to be considered with respect to the homogeneous transformations with the trigonometric conditions cos theta and sin theta. That the theta value will be applied here. That will be substituting and finding the values. Right. So here two conditions has been given, translation and then after the rotation. See, if the reference frame system B is rotated pi by 2, so pi, you know, almost the value is 180 reference pi by 2 around the axis Z of reference system A, and calculate the components of vector APE final point, given that the frame with respect to the base A, B to E, that is 4 comma 8 comma 12. We need to find with respect to the base A, that is here there is an origin A. We're having APE, that is 4 8 12 is equal to NPE, that is 8 minus 4 12. So after getting considered with respect to the reference frame, that is origin, it is the value. But we have given the value with respect to only the base frame B to point from B linked to end effector, that is 4 comma 8 comma 12. So rotation pi by 2 axis along with the z axis need to be considered. That is the first phenomena. Next one, that rotations will be processing here. Hence, the composition agitations. So composition in the sense here, both the rotations as well as the translations. We'll be having one example. See, considering an example, a transformation matrix that represents the rotation of psi1 around the x frame or x-axis, followed by the rotation of psi2 around the y-axis, and the family of rotation of psi3 around the z-axis, can be obtained from combining three ways homogeneous transformation matrices in the following way. See here in the question, it is given in detail that rotation towards the x-axis need to be considered. Rotations towards the y-axis need to be considered. Simultaneously, rotations towards the three axis also should be considered. So in the previous session, we have a detailed look towards these frames, towards these conditions, that how the homogeneous transformations need to be progressed in the case of homogeneous transformations, right? Homogeneous transformations. So in the homogeneous transformations, we have the formulations related to the x, y, and next we have derived a particular transformatory results towards the x comma y comma z conditions in the case of rotations as well as revolutions related to the transformations that has been considered. So in that, okay, let's have a detailed look here itself. Yes. Rotations towards the z, rotations towards the y, rotations towards the x. So in the z, we are having the values of cos theta minus sin theta 0, 1, and 0, 0, 0, 1, and sin theta, cos theta 0, 1, 0, 0, 0, 1. So in such a way, the homogeneous transformations, we are having the detailed formulations in the case of x-axis rotation, in the case of y-axis rotation, in the case of z-axis rotations also. The values which has been given here need to be considered at the positions over there for its rotations. See, these are the formulations. In the previous class, in the kinematics, we have a detailed look. So rotations towards the z-axis, rotations towards the y-axis, and rotations towards the x-axis. So the theta which is having the orientation towards the z-axis, we need to confine this formulation. It is being happening in the three-dimensional coordinate system. It is cos theta minus sin theta 0, 0, sin theta cos theta 0, 0, and 0, 0, 1, 0, 0, 0, 0, 1. And the theta value which has been given in the present question need to be substituted here, and the value which is being obtained here will be calculated or multiplied with respect to the value which is occupied or obtained in the case of y. So rotation in the case of y also is given in the question. So here, in the case of this y rotation, we are having the detailed formula, that's cos theta 0, sin theta 0, 0, 1, 0, 0, minus sin theta 0, cos theta 0, 0, 0, 0, 1. Rotation matrix towards the x, and the theta will be substituted in the place of this value. The value 1, 0, 0, 0, 0 cos theta minus theta 0, 0 sin theta cos theta 0, 0, 0, 0, 1. Right? So in the our today's question, it is confined towards that rotation towards the Z frame, rotation towards the Y frame, and towards the X frame also given in detail. And the theta value will be specified. Either it may be of 30 degrees or 60 degrees or 45 degrees, 90 degrees, 180, whatsoever. That value will be entering in that place of formulation. So after getting one value, that will be multiplied with respect to another value. And that will be multiplied after having three values will be commonly addressing value. So that commonly will be having addressed will take a long time period to calculate. So the combination of these three axis formulations has been given here successfully. So upon applying directly the theta value with respect to these trigonometric conditions, the rotations will be progressed from point base from A to the B, and obviously will be having the solution in only one step, or else we can formulate and calculate the value by substituting theta value in z axis. We'll be getting one value, nothing but here and there. The theta value, for example, regarding the z axis, it is 45 degrees. So here we will be having one value, and with respect to y is 30 degrees sister and we'll be having another value here, matrix, and these two matrices should be multiplied, and we will be getting the result one matrix. That one matrix need to be multiplied with respect to the result obtained with respect to this x, and if those two has been multiplied, we'll be having another one more result, and it involves series of 1, 2, 3, and upon these two calculations, another one step will be obtained. That step need to be multiplied with respect to this rotation x, and upon those two calculations, we'll be having the final answer. So this 3 plus 1, and there are one step calculations 4, and finally we'll be obtaining the value at the step 5. So 5 different steps are existing. So instead of having 5 different steps, and this is the formulation related to final aspect, nothing but getting the answer quickly upon substituting the theta directly in this values, C3, C2, C3 of sine value regarding the second frame and sine value related to the first frame or first link, and minus of S3 C1 plus C3 S2 C1. C3 in the sense cos value, sine value of link 2, cos value of link 1, plus of sine value of 3, sine value of 1. Simultaneously, in the case of this second frame, sine value, cos value, sine value of third link, second link, first link, plus cos value of 3, cos value of 1, sine value of 3, sine value of 2, cos value of 1, minus of cos value of 3 and sine value of 1, and minus S2, C2 S1, C2 C1 0. So here the values will be of referred 1, 2, and 3, and this will be the final strategy. See this rotation, in the case of this rotation also, this is the value of x, this is the value of y, this is the value of z. And there in the our previous class notation, we have been formulated as theta here side. Don't bother about that. For our convenience, we'll be changing the significations, and we'll be substituting the theta value in place of this side. And this is regarding the first rotation, second rotation, third rotation. Right? Upon cross multiplication, we'll be having the gratitude solution. So this transpose from the transformation of rotation from base frame A to the B. So C3 C2 minus S3 C2 S2 0. And this is the overall calculations. Instead of having three different long steps, we'll be getting the answer in only one step upon substituting this theta values in the case of rotations. And in the case of Transformations also similar strategy. So in conclusion, there's the basic homogeneous transformations regarding this transformations, prismatic moments and the rotation moments. Right. For these combined transformations, we'll be seeing the examples of problems, solving of the problems in the next class. Thank you.